This goes very quick because we're doing the exact same thing with angles that we did with segments. We have to name them, measure them, add them, bisect them. So we're going to do the same things, but it all happens right here, right now. So let's do it. We have the angle addition postulate, which, if you remember the segment addition postulate, this will be very similar. With segment addition, we said we can add the little segment plus the little segment after it, and that's going to give us the whole thing. So if we write it out, AB plus BC equals AC. The only difference here is that we have more letters. So we have the first angle, then we have the second angle right next to it, and together that's going to make the big angle. So if you think about it, we're really doing the exact same thing. That first little angle, the yellow one, is angle RSP. And the second one, the purple one, is angle PST. So the first little angle and the second little angle. And together, they make the whole thing, which is angle RST. So that's what we have up here. We have angle RSP. And again, M in front of it just means measurement. Plus the angle next to it, angle PST, equals the big angle, angle RST. It works exactly the same as segment addition. There's just more letters. A segment takes 2 letters, an angle takes 3 letters, the angle symbol, and then sometimes we see the M in front of it. But it's the same exact concept. So we have the angle addition postulate. Okay. So again, we can use that angle addition postulate whenever the angles are adjacent, meaning they're right next to each other. They have to share the vertex and the line that separates them. One angle goes out that way, the other one goes out that way. And together, we can add their totals. That's all this means. So let's look at the angle addition postulate being used here. Always find the part that they're talking about. So I'm not worried about the numbers or the algebra. I want to find the part. So angle YDK. YDK. That's the little angle. Angle KDL. KDL. So right now I know this little angle is 35 degrees and this little angle is 90. Now it might not look it, the drawing might not be accurate, but that doesn't matter. We're asked to find YDL. Well, look at it. The yellow plus the purple equals the green. And we can certainly write it out. Angle YDK plus angle KDL equals angle YDL. So 35 plus 90, and we get 125 degrees is the measurement of YDL. And each of these questions is going to work the same way. So I'll do one more. I'm going to erase what I labeled in the picture. And let's take a look at number 3. YDK. YDK. And that angle is 2x plus 5. KDL. Well, that's the one right next to it. And that's 5x minus 10. YDL. YDL. YDL is the whole thing. And for that, they gave us 4x plus 28. Little angle plus little angle equals big angle. So we're still going to do the same angle addition. The picture didn't change, so the angle addition statement doesn't change. Same exact idea as we had with segments. If the picture didn't change, the segment addition didn't change. Well, the picture didn't change, so the angle addition doesn't change. Let's just plug it in. We have 2x plus 5. KDL is 5x minus 10. And then YDL is 4x plus 28. And we're going to do some algebra. I'm just going to slide my screen a little bit. So let's see what we have here. We have 7x minus 5 equals 4x plus 28. So 3x, we're going to add 33, and x equals 11. But notice what they asked us to find. They asked us to find KDL. So we're going to take KDL, and we're going to plug it in. So 55 minus 10, and we get angle KDL. The measurement of angle KDL equals 45, and our units are degrees. Now again, the picture might not be drawn accurately. The picture is a reference, so we can determine what rules to use. So we have some angle addition. All right, so the next thing we have here is an angle bisector. And again, we did this with segments. When we bisect something, we break it into two smaller, congruent, and equal things. So when we bisect a segment, we get smaller segments. When we bisect an angle, we get smaller angles. What's happening here is that we have the big angle, NML, and then ray MP comes along and goes right down the center, cutting it in half. Now, we're not getting congruent sides, meaning MN and ML are not congruent. We don't know anything about them. One could be 2 inches and the other one 10 miles. What we're saying is that the angle NMP and the angle PML are congruent and their measurements are equal. So the angles are congruent and their measurements are equal. We did this with segments. We're doing the exact same thing with our angles. If I bisect an angle, I get two smaller angles that are congruent and their measurements are equal. So if I know one, I know the other. If I double one, I get the whole thing. We're taking this big angle and we're splitting it exactly in half, again, in degrees. So if we had a right angle, now we have two 45-degree angles. It does not affect the length of their sides. So think about it that way. It does not affect the length of their sides. If I have a right angle and I bisect the angle. Now those sides are definitely not congruent. If I bisect the angle, I didn't change the length of the two sides. I just made each of these 45 degrees. The length of the two sides didn't change and magically become congruent. We're talking about the smaller angles. And we're going to do the exact same kinds of problems we did with segments. So let's take a quick look here. Now we have to draw this one ourselves. BR bisects LRM. Well, think about that. We can't draw the bisector first. We need the angle first. So we're going to have to start with an angle LRM. Now, I don't know if it's acute, obtuse, or right. I'm not going to draw a right because I don't want to trick myself into thinking that's what it's supposed to be. I'm just going to give myself a nice big angle. I don't know what it's supposed to be. L, remember the middle letter is always the vertex. R, M. Now, a segment called BR bisects it. Well, I already have R in the picture. I can't have two R's. So I guess B is out here. And I want to show it in the picture, so I'm going to put little arcs on it. And one arc in each means congruent, just like one hash mark on a segment meant congruent. Sometimes you'll also see people put little hash marks on them. And again, that just means they're congruent. That's all it means. That's important, though. So let's see. Let's see what they're giving us to work with here. LRB. LRB. MRB. MRB. I didn't look at the algebra. I don't care what the algebra says. I care about those two parts, the yellow and the purple angles. Well, how are they related to each other? What do I know about them? Well, they're congruent. We already said it. We already marked it in the picture. We don't even have to think about it anymore. The big angle was bisected, so angle LRB is congruent to angle MRB, which means the measurement of angle LRB is equal to the measurement of angle MRB. And those are the ones that they gave us algebra for. So LRB is 3x plus 4. MRB is 8x minus 21. Notice this looks exactly like the work we did for segments. We're going to find x, so subtract 3x, add 21, and x equals 5. But the question asked us to find LRM. Well, LRM is the whole thing. So just like we did with segments, we're going to plug that x back in everywhere. Three times 5 plus 4 is 19. So this one is 19 degrees. 8 times 5 minus 21. So that's 4 minus 21 is 19 degrees. Well, we expected them to be equal. They are the result of being bisected. So now, how big is the whole thing? Angle LRM. Well, we use our angle addition. Angle LRB plus angle MRB equals angle LRM. 19, 19, plus 19. So 38 degrees is angle LRM. And again, a little m in front of it, technically. And we have our answer. Guys, this is why we spent so much time on the segments, because what we did in 3 or 4 days with segments all of a sudden happens in 1 or 2 days with angles, because it's the exact same thing. All right, I'm going to stop there, and let's get some practice on it.